Okay, continuing on now with question 11 and 12 from exercise 2b on the intermediate questions now. And question 11 says, given that n is a positive whole number, write n root 15 take away root 5 all squared in the form a plus b root 3. And it looks like to me this is just a case of expanding the double brackets and then trying to get it into the correct form. So let's go through it, just working through it really carefully. So we're saying we've got n root 15 take away root 5, and we're squaring the whole bracket, so we're just timesing the bracket by itself. So n root 15 take away root 5. And just a case of working through this carefully, multiplying out the brackets, okay, like we know how to do. So first by first term, first by second, second by first, and then second by second. So first of all, we've got n root 15 times by n root 15. Well, n times by n, first of all, is going to give you n squared, so we can write it as n squared. We've then got root 15 times by that root 15 is going to give you root 225, which you can simplify, of course, down to 15, but I'm going to keep it as this for the time being. We've then got negative root 15 times by we've got n root 15 times by negative root 5, which is going to give you negative root 15 times by 5 is 75, so negative root 75 n. And then you've got the same thing again, because you've got negative root 5 times by n root 15, so you've got the same thing again, so negative root 75 times by n. You've then got a negative root 5 times by a negative root 5. The two negatives will give you a positive, so it's going to give you plus root 5 by 5 is 25. Let's do some simplifying now. So this root 225, of course, goes down to 15. So you've got 15 n squared. And then root 75, I'm just thinking you can simplify this down further, because root 75 you can write as two numbers times together by one of them is a square number, where that number is 25. So 25 times by 3. So you can write this as 5 root 3, which is good. So that's where that root 3 part is coming into play. So we can then write this part as negative 5 root 3n. I've just replaced that negative root 75 with negative 5 root 3. You've got the same thing going on again. So you've got negative 5 root 3n again. And of course, root 25, we know, is just equal to positive 5. So, or minus 5, but plus 5, right, in these questions. Good. And then it's just a case of here of getting it into the right form, really. So first of all, I'm noticing that, of course, these are like terms. Negative 5 root 3n take away negative 5 root 3n. We can simplify down. So we're going to be getting 15 n squared take away 10 root 3n by looking at the green parts. We've got that plus 5 on the end. Okay, but we want to get it into this form up here. Now, don't be confused by the n squared and the n. These are it's just a whole number. So just treat it as it is a number. But you want to have the root 3 on the end on its own. So we can then rewrite this a bit differently and say we have got 15 n squared, okay, plus 5. So that n squared is just a number. So we're just saying that this part here, okay, the 15 n squared plus 5, this is your a part. And then you've got negative 10 root 3n, which I'm going to write a bit differently. No, that's fine. I'm going to write it as negative 10 root 3. Sorry, no, I'm not going to write it as negative 10 root 3, because again, that n just represents a number, okay? So that's just the b part. So that negative 10n is the b part. And you can see, right, it is in the form a, where a is equal to 15n squared plus 5. That's just a number, that n squared part. And then take away 10n, that negative 10n is your b part, root 3. And that is your first answer. Okay, so good. Question number 12 is this. It says a rectangle has a length a plus b root 2 and a width b take away a root 2. Find the area of the rectangle and write it in the form m plus n root 2. So we want to find the area here. I always think it's always good to draw a bit of a diagram. Hopefully we know that the area is going to be the length times your width, but always good to draw things out. So we've got some sort of width and some sort of length going on here. Okay, and then we know that the length of the rectangle is a plus b root 2, with the width of it is equal to b, take away a root 2. Okay, to find the area, the space inside the middle, you just times your length with your width. This is part a, so we're just doing a plus b root 2, and we're timesing it by b, take away a root 2. Okay, we're just going through again by expanding our pair of double brackets, first term by first term, multiplying, first by second by first, second by second, being really careful as we work through it. We want to write this in the form m plus n root 2. Okay, so first of all, write a times by b. We're just going to simply write as ab, so we get AB. We've then got a times by negative a root 2 is going to be negative a squared root 2. We've then got a b root 2 times by b is going to be plus b squared, so plus b squared root 2. Then we've got a b root 2 times by a negative a root 2 is going to be negative a b. Root 2 times by root 2 is root 4, so it's going to simplify down to 2, so it's going to give you negative 2 ab. I've just simplified it in one go, so negative 2 ab. Good. And then what I'm noticing here is actually that these parts here, this AB and this negative 2AB, they're like terms because they both end with an AB. So you've got 1AB, take away 2 lots of AB, which is going to give you negative 1AB, which is negative AB. So we've got negative AB. And then because I can see in the question we want to have something root 2, I want to factorize out the root 2 from the a squared and the b squared. So I'm going to go and factorize out the root 2 from this statement here, which is going to give me plus, I can write it as b squared, take away a squared, and then root 2 on the end. Okay, and that is my answer, because the m part, sorry, this is my m part down here, that's m, and then my b part is over here. So it's b squared take away a squared, that's the n part. Okay, and that is my answer. So there we go, give that a bit of a highlight. Fantastic. Good. Okay, question B is saying find and simplify an expression for the length of the diagonal of the rectangle. So it's saying we want to now go and find the length of this diagonal here. Okay, and we're thinking hopefully right angle triangle, because this here is a right angle, Pythagoras. Okay, so it's just a case of going back to GCSE stuff and knowing, well, that your longest side is C, what you're trying to find, where these two sides are A and B. Okay, so I want to find an expression for the length of the diagonal of the rectangle. Okay, and we know that Pythagoras is a squared plus b squared is equal to c squared. And just working through this, being really careful when we kind of go through this. So we know that a is equal to a plus b root 2, so it's going to be a plus b root 2, and we are squaring this, and then we've got b squared, which is going to be, well, b is b minus a root 2, and we're squaring that, and of course that is equal to your longest side, c squared, that we're trying to find. Okay, and then just a case of working through this, being really, really careful. So the first bracket is going to give us a plus b root 2. We're squaring it, so we're just timesing it by itself, a plus b root 2. That's the first bracket. We've then got the second bracket, which is going to be b take away a root 2, and we're timesing it by itself, b take away a root 2, and that all being equal to c squared. And then we just got to go carefully and work through expanding our pairs of double brackets. Okay, and just making sure we're not making mistakes here, because it will hopefully kind of cancel down, giving us something a little bit nicer. So the first bracket, a by a, is going to give you a squared. We've then got a by b root 2, which is going to give you plus ab root 2. But of course, you've got two lots of it because you've got a b root 2, b root 2a, which is again is of course plus ab root 2. You then got b root 2 times by b root 2. Well, b times by b is b squared, so it's going to be plus b squared, but you've got that root 2 times by root 2, which is root 4, which simplifies down to 2. So it's going to be 2 lots of b squared, and then we're adding on to that, we've got a b times by a b, which is b squared, so plus b squared. You've got a b by a negative a root 2, so it's going to give you negative a b root 2, and then you've got it again because you've got it here as well, so it's going to be negative a b root 2 again, and then you've got a negative a root 2 by negative a root 2. Well, the negative will give you a positive, so it's going to give you positive a squared, okay, and then of course root 2 by root 2 is root 4, and root 4 is 2, so plus 2a squared, and there we go, and that is all equal to your c squared. And now we're just going to kind of go and cancel out and maybe combine like terms here. I'm noticing straight away that I've got an ab root 2 plus ab root 2 and a minus ab root 2 that are going to cancel. I've got a plus ab root 2 and another minus ab root 2 that cancel, okay, which is good. And I'm left with like terms of an a squared and a plus 2a squared, and then I've got a plus 2b squared and a b squared. So putting it all together, a squared and 2a squared, it's going to give me 3a squared. B squared and 2b squared is going to give me plus 3b squared. That is equal to c squared. I want to find the length, which is just c, so I've got to go and square root both sides now and say that c is equal to the square root of 3a squared plus 3b squared. Okay. I want to write the expression in its simplest form, so what I could go and do here is I could go and perhaps factorize out a 3 and say I've got 3 bracket a squared plus b squared, which I believe is your answer. I'm just looking at that again actually, and probably you could simplify it a little bit further if you wanted to. I don't see why you couldn't go and do c being equal to the root of 3, and we know that's being times by the root of a squared plus b squared, which you can go and write as a plus b squared. No, we'll leave it as that. That's fine. That's fine. We'll leave it like this. That's good. Okay, I don't want to confuse us there. Okay, good. So I believe that is it actually for the video. So yeah, good. Sorry, right. Just thinking a little bit there. Good. So on to the red questions on the next video. Hopefully that was useful. I will zoom out so you can see the full slide. There we go. Perfect. Good.